So now this video discusses on how we can be able to determine the range as the domain of the function analytically. And for the sake of interest, we'll be looking at the functions like we'll be looking at what we call them as the linear functions. We'll be looking at the linear functions. We'll be looking at the quadratic functions. We'll also be looking at what we call them as the polynomial functions. We'll also be looking at the rational functions. And we should also have to understand about, the square root functions. Should be that square root functions. And we'll also be looking at what we call it as should be the cube root function. Should be the cube root functions, and there should be that. And of course, we'll be looking at what we call them as the mixed fractions. That is the fractions with the linear and mixing with the square root and sort of. But we just have to concentrate on these functions in our actually analysis. And of course, in later times, we'll be discussing about the functions like trigonometric functions, the likes of, let's say, the exponential functions, and other functions of interest that we're going to look up to in the later times. But now we just have to concentrate on how we can be able to determine the range as the domain of these functions analytically. Let's start with a linear function. So a linear function, it is a function whose highest degree power is given as 1. And the typical linear function is given as f of x is equal to, let's say, ax and plus, let's say, bx and plus c. Of course, let me present that one as this. We can have it as should be mx and plus c. This is a typical, actually, a linear function. And basically, the function, it is of variable x with the highest degree power given as 1. Of course, 1 is silent, but that's actually a linear function. So in all cases, this function is defined for each and every value of x. So x can be negative or positive, the function will be defined. Hence, the domain of the function is said to be all real numbers from negative infinity to positive infinity. So that's how you start to understand about the domain of the linear functions. And let's have the following cases. Later we have the function f of x is equal to, let's say, negative x plus 2. Now the domain of this function, ranges from negative infinity to positive infinity. That is the domain of the function. All real values, the function will be defined. And what if, let's say, we have the function f of x, which is equal to, let's say, 2x and plus 5. Principle remains the same. The function will be defined for all real values from negative infinity to positive infinity. So that's how you start to understand that one. And let's go for what we call them as the quadratic functions. So quadratic functions, these are the functions of highest degree power given as actually should be 2. By the way, before we go for the quadratic, let me give you another example for the linear function. Let's say if we have the function f of x is equal to x plus 1 divided by, let's say, 5. Should we say this is a linear function or not? Now this is a typical linear function because, because on the denominator we have the constant number, which is 5. Now for this case, the numerator only has actually a variable. Hence, this is atypical. Now this is atypical, actually a linear function, despite that we have it as a fraction. But now since on the denominator we have the constant number, then this is a typical, actually a linear function, in the sense that the domain will be given as all values of x, and are from negative infinity to positive infinity. And for the sake of interest, even if we can have, let's say, f of x is equal to, let's say, should be that of, let's say we have 10 minus 6x divided by, let's say, 7. So this is a linear function, and since on the denominator we have the constant, and on the numerator we have the x with the highest degree power given as should be 1. So if that is the case, this is also part of the linear function. And otherwise, this can be expressed as f of x is equal to negative 6x divided by 7, and plus 10 divided by 7. So as you can see, this is a typical linear function as it is there. So a linear function, it is the function whose highest degree is given as 1, and basically the inputs are actually all real numbers from negative to positive, that is. And how about square root functions? Square root functions, these are the functions that should be a quadratic functions, not a square, but should be quadratic functions. So how about the quadratic functions? So quadratic functions, these are the functions with the highest degree power given as 2. And basically, they take the form of f of x is equal to ax squared, plus bx plus c. This is a typical quadratic function, and it is the function of variable x with the highest degree power given as 2. Now, in all cases, the quadratic function, inputs or the domain ranges from negative infinity to positive infinity. In other words, all real values, will make the function to be defined. Hence, the domain has to be negative infinity to positive infinity. Let's have this, and for the sake of interest, let's say if we have the function f of x is equal to, let's say, negative 2x squared plus, let's say, 5x plus 1. Now, the domain of this function, x can be any other value for interest. The function will be defined. Hence, the domain will be given as the negative infinity to positive infinity, like that. And how about, let's say if we have this, let's say if we have the function f of x, let's say we have a negative x squared plus 4x minus 1 divided by, let's say, 7. Remember, this is a quadratic function. And since we have the numerator, since we have the denominator with a constant, so only the variables are on the numerator. And since the highest degree given us 2, this is a typical quadratic function. So in this case, the domain ranges from negative infinity to positive infinity. So that's how you should have it. So in all cases, the quadratic functions, bears the domain as the all real values you may think about. And let's go for the polynomial functions. So polynomial functions, these are the functions whose highest degree power ranges can be from 3 up to so like that. And they take the general form of f of x is equal to ax to the power 3 plus bx squared plus cx, can be that, of course, and plus d. And basically we can have some with the highest degree power 5, 6, and sort of. In all cases, the function, the inputs of the function can be any other value, either negative or positive. Therefore, the domain of the function, ranges from negative infinity to positive infinity. So that's how you start to understand about the inputs of the polynomial functions. Let's say if we have the function given as 2x cubed, let's say minus 5x squared plus 4x minus 1. Strummer, the domain of the function ranges from negative infinity to positive infinity. And sometimes, the linear functions, quadratic functions, and the polynomial functions are regarded as the open functions, since they actually accept all real values as their inputs. So keep that in mind. And now let's go for what we call them as the rational functions. So rational functions, these are the functions that are fraction in nature, and basically they contains the variable on the denominator as well as the numerator. And for instance, let's say if we have the function, f of x is equal to, let's say, m divided by n. Let's say this is a typical function where we have on top a variable and also down a variable. If that is the case, in all cases you have to understand that given a fraction is only be undefined when we have the denominator as 0. Hence, you have to understand that since this is a rational function, n should not be equal to 0 in all cases. Denominator can be any other value apart from having it as 0. Hence, for the rational functions, the inputs has to be all other values apart from the value that will make the denominator equal to 0. So that's the principle behind. And for instance, let's say if we have the function, let's say f of x is equal to, let's say, 2x minus 1 divided by, let's say, 6x plus, there should be 12. So what is the domain of the function? So according to the principles behind, this is a rational function. The only decider on the inputs of the function should be the denominator, since it should not be equal to 0. Hence, we should have to understand that 6x plus 12 should not be equal to 0 in all cases. Then we should have to solve for the value of x that will make the function, that will make the denominator equal to 0 in that way. So in this case, we'll have to bring 12 to the other side. That will be given as 6x should not be equal to negative 12, should be that. And the x should not be equal to negative 2. So which means in all cases, the domain of the function can be any other value apart from x being given as negative 2. Then we should have to present that on the number line, and we should have to generate the intervals corresponding to the set of the domain. We have negative 2, and since 2 should not be part of the interval or the part of the domain, we use these brackets. We call them as open brackets. So for this case, what it means is that the domain has to be negative infinity to negative 2, and union should be 2 comma positive infinity. So this is the set of the domain of the function. So what it tells is that the domain can be any other value, positive or negative, apart from it being given as the negative 2, because the function will be undefined when x is negative 2. What if, let's say, we have the function f of x is equal to, let's say, 6x plus 2, and divided by, let's say, x squared minus 4. So how do you think we should have the domain of the function? Principle remains the same. Since this is a typical fraction function, denominator should not be equal to 0 if that is the case. And let us see how we can have to determine the values of x that will make the denominator equal to 0. Now these are difference of two squares. We'll have x minus 2 and times x plus 2 should not be equal to 0. If that is the case, x should not be equal to 2 and x should not be equal to negative 2. So what it means is that the domain can be any other value, positive or negative, apart from having positive 2 or negative 2, because the function will be undefined. In that sense, they'll give us 0 on the denominator rather. We should have that. And we should have to generate the intervals corresponding to the set of the domain. And this is a positive infinity, and this is the negative infinity. We'll have negative 2 here and a positive 2. And mind you, you have the full knowledge on the number line. So keep that in mind. And how should you have the set of the domain for this case? Now the domain will be given as the negative infinity and comma negative 2, and that is union negative 2 to positive 2. And since they are not part of interval, and union 2 to positive infinity, so that is the set of the domain of the function. And what if, let's say, we have this kind of a case under preset as well? Let's say if we have the function f of x, let's say given as 5 divided by x squared, and let's say x minus 12. So how do you think we should have the domain of the function if this is the case? Stromos, this is a typical rational function. The only decider of the inputs has to be the denominator, and in the sense that the denominator should not be equal to 0. In all cases, you should have that one. And I should have to factorize that one and determine the value of x, the values of x that will make the function, that is making the denominator equal to 0. And that also we should have to use the factor method. And we should have it as x squared, and plus we'll have it as 4x minus 3x, and the minus 12 should not be equal to 0. And for that case, we'll have to pair up these. We'll have it as x plus 4, and the minus 3, x plus 4. We should have that. And mind you, you are all conversant with the methods of solving quadratic equations. Otherwise, it is not always that you have to solve this using the factor method. You may think of using the quadratic formula or the completing square method. That can also work as well. And for this case, we'll have x plus 4 times should be x minus 3, and that should not be equal to 0. And hence we'll have x not being equal to 4 should be negative 4, and x not be equal to positive 3. And we should have to present this on the number line and have the domain in terms of the intervals. But at the end of the day, you have to understand that the input of the domain can be any other value apart from having x negative 4 and x positive 3. And we should have this on the number line. This is the negative infinity and this is the positive infinity. We have negative 4 and negative 3, and the intervals are these as that. So try to finish that on your own. And also, for the sake of interest, in our practice, try to have this. What if we have the function f of x is equal to, let's say, x minus 2 divided by, let's say, 5 minus x? How should we have that one? And let's say you have the function f of x is equal to, let's say, negative x divided by, let's say, negative 6x, then plus, let's say, 18. How should you have the domain of the function? And what if we have, let's say, the function f of x given as x plus 5 divided by, let's say, x squared and plus 2x? It should be that in the minus 8. So try to have to deduce the domain of the function and present them in the interval notation. And basically, you need to present them in the interval notation as I'm doing it here. So keep that in mind. And now let's go for what we call them as the square root functions. Now, square root functions, these are the functions that are under square root. And let's say we have the function f of x is equal to, let's say, the square root of m. So as you can see, the function of f of x is under actually a square root. That's what we get as the square root function. So in all cases, let's try to have this, and try to have a calculator by your side, and try to plug in the square root of, let's say, 0, and tell me what would be that. And what is the square root of, let's say, negative 5? What is that? And what is the square root of, let's say, negative 10? What is that? And what is the square root of 5? And choose any positive value. So you observe that the function, you observe that the calculator will give you a math error on the square root of any negative number. So what you have to understand is that the square root of any negative number is undefined. In other words, the square root only accommodates a positive values including 0. You see that the square root of 0 will be given as 0. So in all cases, the square root actually accommodates 0 and all positive values. In other words, all roots whose carrier is even number, they accommodate inputs as 0 as well as the positive values. And for instance, even the fourth root of 0 is 0, fourth root of, let's say, a 5 is defined, let's say, eighth root of, let's say, a 3 is defined, but the roots of even numbers, the roots of the even numbers, like, let's say, 2, 4, 6, 8, and sort of, they do not accommodate, a negative inputs. They only accommodate positives, including 0. And should be that. And for instance, if this is the case, now the domain of the function, m should be greater than or equal to 0 if that is the case, since this is the square root that accommodates actually the inputs from 0 to positive. So that's how you start to understand about that one. And as you can see, on the square root, as you can see on the square root, actually functions, the domain of the functions are inequality based. Hence, you should be well oriented with solving linear inequalities and also solving the polynomial inequalities. Those are the things that will be used in the actually discussions, as will be appreciated as well. So keep that in mind. Let's say if we have the function f of x is equal, let's say, square root of x plus 2. So what do you think will be the input of the function? Now, since this is the square root function, in all cases x plus 2 should be greater than or equal to 0, and hence what we have here is linear inequality. We have it as x greater than or equal to negative 2, and we can think of presenting this in interval notation. We'll have it as negative 2 being part of interval to actually positive infinity. So this is how we should have the domain of the function. So which means if we can have negative 2 here, have the square root of 0 that is defined. But apart from that one, then we can also have, let's say, negative 2 that is negative 1 that is okay as well. Should be negative 1 that will also be okay as well. That is okay as well. Let's say a 0 that will be okay. But whichever the value that will make the function be undefined will not be part of interval. And for instance, those values that are actually below negative 2 to make the function to be undefined. Hence, this is the set of the domain of the function. And what if, let's say, we have this kind of a function? We have, let's say, f of x is equal to, let's say, the square of x squared, let's say, minus 4. So how do you think we should have the domain of the function? Now, this is a typical actually square root function in the sense that the domain will be given as x squared minus 4 should not be equal to, should be greater than or equal to 0 according to the state of affair, where we should have to factorize those using the difference of two squares. We'll have x minus 2 at the times x plus 2, and that is greater than or equal to 0. For that case, we'll have x being given as positive 2 and x being given as negative 2. These are said to be the key values. Now, since this is a linear, actually this is an inequality, inequality polynomial, what you have to understand is we'll have to come up with what we call that as, we need to generate the intervals, and from there we have to use the testing table to test which interval satisfies the conditions of having that as a domain or not. So we have the positive infinity, we have this is negative infinity. So the same knowledge we discussed about solving linear inequalities, polynomial inequalities, it is the same way we're doing it here. In case you need of that one, just have to check GP Analytical School of Science solving inequality polynomials. You come across all these things. And now for this case, we have, now despite the actually inequality symbol, let's use these actually brackets. Otherwise, we'll come back to this in the typical solution. Now, what are the intervals we can generate here? We have negative infinity and a negative 2 like that, and we have negative 2, positive 2, and we have positive 2 to positive infinity. These are the intervals that we can have from the actually the key values in the number line. And the next from there, we should have to come up with the testing table. It should be the testing table, by the way. We should have to come up with a testing table, and that consists of the intervals. We do have the intervals, then the test number. We should have the test number here, and we do have where we should have to test number in. So we actually present the simplified version of the equation. We'll have x minus 2 and the times x plus 2. Of course, some scholars do separate the columns of this, but in all cases, this is the same as that. And we'll have the conclusion column here. So how should you have it? The first interval is negative infinity to negative 2. So we should have to choose any value within this interval apart from negative 2. So let's think of choosing, let's say, negative 3. And now for this case, we should have to substitute negative 3 in this. So how should you have it? So negative 3 here we have it as negative 5. And negative 3 here we have negative 1. Negative 1 times negative 5, that is a positive 5. Here the conclusion will be positive. And what's the next interval? We have negative 2, positive 2. So which value should we choose? Let's think of having, let's say, 0. Now for this case, 0 here we'll have negative 2 and we'll have positive 2. That will be given as negative 4. And the conclusion is negative. In the next interval, we have it as 2 to positive infinity. And what should we actually, which value should we be? Should we have to select? Let's think of having 3, the one which is in the interval. and 3 here, that is a positive 1, and 3 here, that is 5. So 1 times 5, that is 5. And since it is positive number, we'll have the positive conclusion there. So keep that in mind. And now, as you can see, our actually inequality favors the positive values, since it is greater than or equal to 0. It means we're looking for the positive values. Hence, the set of the domain will be the intervals with a positive conclusion. Hence, the domain will be given as negative infinity to negative 2. Now, since we are having that particular symbol, then that's when we now have to think of having negative 2 as part of interval. So have negative 2 part of interval union, then we'll have positive 2 part of interval to positive infinity. So that's how we should have it there. So that's the principle behind actually that kind of a case, as you can see. Let's say if we have a function f of x is equal to, let's say, the square root of should be x squared. Let me have this. Let's say x squared minus x, let's say, minus 12. So how do you think we should have the domain of the function? So in this case, this is still more a squared function, and where we understand that the domain has to be x squared minus x minus 12 should be greater than or equal to 0. And hence what we have is that of the linear actually inequality polynomial. And from there you can have the way we have done it before, where you factorize this, you come up with the intervals, the testing table, and sort of. And also try this one as well. Right? Say if we have f of x, it should be square root of x squared, and the price, let's say, 2x. So how do you think we should have this? Principle remains the same, where we have to do it in the same way. And also at your own time, try to go through the following cases and appreciate. Let's say if we have f of x is equal, let's say, the square root should be x plus 5, should be plus 8. So how do you think we can have this? Principle remains the same. X plus 8 should be greater than or equal to 0. So this is a linear inequality, and you do it in the same way as far as solving linear inequalities is concerned. And now let's have to look at how we can have to determine should be the domain of the cuboid functions. Now cuboid functions, these are the functions under cube root, and basically f of x, let's say I have f of x is equal to the cube root of, let's say, m. So in all cases under cube root, the domain can be any other value, either positive or negative. So that will be that. And let's say if we have the function, let's say f of x, let's say if we have the function f of x is equal, let's say, the cube root of 5x minus 1, in this case the domain will be any other value that is negative infinity to positive infinity. So in other ways, under actually a root with should be you should have to understand that under roots, I should say, let me just have to say it this way. Let's say if we have a root of, let's say, nth root. Let's say we have the function f of x is equal to nth root. Let's say nth root of, let's say, should be x. Now for this case, if n is an even number, the input of the function, which is x, should have to range from 0 to positive infinity. So any other positive value, including 0, will be the part of the input. So that's why we are saying x should be greater than or equal to 0. But if n is an odd number, which is not an even number, then the inputs is any other value we think about. So in other ways, the roots with even the roots with the actually odd numbers should be the roots with the odd numbers, accommodates positives or negatives. And for your own information, think of having, let's say, cube root of, let's say, -5. It will be defined. You'll be able to have that one. And let's say 7th root of, let's say, -7 will also be able to give you something rather than undefined. So that's how you should have to understand that. Let's say if we have the function f of x is equal to, let's say, cube root of 6x plus 1. You know, principle means the same. Since this is the cube root, so the domain of the function, you know, range from -8 to +8. In other words, under square root, under cube root, negatives are part of the inputs as well. But now, what if we have the combination of the fraction as the cube root? Let's say if we have the function f of x is equal to, let's say, the cube root of, let's say, x plus 1 divided by, let's say, x plus 5. So how do you think we should have the domain of the function? Now we understand that under cube root, any actually a value of input is acceptable, either positive or negative. The only decider of the inputs of the function has to be the denominator. Hence, in all cases, x plus 5 should not be equal to 0. So you can take it from here. And what if, let's say, we have the function f of x, let's say, is equal to the cube root of, let's say, 5 minus 2 divided by, let's say, x squared and the plus x minus 12. You know, in all cases, since the whole function is under cube root, you know, under cube root, all values of inputs are acceptable. Should be that, but the only decider of the inputs has to be the denominator, since we have the fraction inside. And therefore, according to the principles behind, we have x squared plus x minus 12 should not be equal to 0. Hence, we can take it from there. And now, let's see if we have the mixture of the square root as well as the fractions. And this is where you should also have to take it serious and be able to understand the concept behind. Let's say if we have a function f of x is equal to, let's say, 2x minus 1 divided by the square root of, let's say, x plus 2. So how do you think we should have the inputs of the function? This is a typical fraction function, in the way, according to the principles behind, the denominator should not be equal to 0. But now the denominator is under square root, and of which under square root the inputs ranges from 0 to positive. But how should you have the condition that will satisfy both of these cases? Now the only condition here is that x plus 2 should be greater than 0. So this is the condition that we use if we have the square root, and actually if we have the fraction with a square root on the denominator. That's the condition we use. So for this case, what we have is a linear inequality. Hence we have x greater than -2. And in interval notation, we have it as should be 2 not part of interval to positive infinity. So that's how we should have it there. And how about, let's say, if we have a function f of x is equal to, let's say, 6x, and divide by the square root of, let's say, should be the square root of, let's say, x squared minus 25. So how should you have the input of the function if this is the case? As you can see, this is a fraction function with a square root, actually with a square root on the denominator. And hence what you should have to understand is that x squared minus 25 should be greater than 0. And this is the condition that will satisfy the inputs of the function, like that. And now what we have, this is a linear, should be polynomial inequality, where you can solve it the way we have been discussing all over. So keep that in mind. And what if, let's say, we have the function f of x is equal to, let's say, 6x minus 12, and let's say divide by the square root of x squared plus x, and let's say minus 24. How do you think we can have this? You know, principle means the same. X squared plus x minus 24 should be greater than 0, and you can take it from there. Now here's the question for you, and I want to hear from you whether you have done it or not. Otherwise, I just have to check through the comment section and see whether I need to give out with the video about that or not. Let's say if we have the function f of x is equal to x plus 1 divided by, let's say, square root of x plus 2, and let's say minus 5. What if we have this case? How do you think we should have the set of the domain if we have this kind of a case? How should we have it? So I want to have the responses from your side, viewers, and how we should have the domain of this kind of a function. And also try to have f of x is equal to, let's say, x minus 1 divided by, let's say, square root of x squared minus 4, and let's say minus 5. And how should we have the domain of this function? So I want to see the responses in the comment section below, whether you are able to have that or not. And what if, let's say, have f of x is equal to, let's say, x minus 1 divided by, let's say, square root of x plus 1, and the minus, let's say, square root of 5x, let's x actually a square root of x plus 5. How do you think we should have the domain of this function? So I want to see the responses in the comment section below, how far you have gone with that one. Otherwise, you may check through, different sources and be able to learn through that one about how you can have to tackle that kind of a case. And now let's finish with a case whereby we have, let's say we have the function f of x is equal, let's say, what if we have the denominator, actually we have the square root on the numerator as well as the denominator. Let's say I have f of x is equal to x plus 2 and divided by square root of, let's say, 5x minus 4. So how do you think we should have the domain of this kind of a function, where we have actually a square root on top as well as the down? So you should have to understand that according to the laws of indices, having, let's say, a square of a over b, this is the same as the square of a divided by square of b. It is the same as that. So at the end of the day, we should have the reverse of this process, in the sense that having that one, it is the same as having it as, having the square of the whole thing, x plus 2 divided by 5x minus 4. So in this case, since the whole thing it is under actually a square root, condition remains the same, in the sense that x plus 2 divided by 5x minus 4, 5x minus 4 should be greater than or equal to 0, according to the principles behind. So still more, you'll be able to, in case you need the more information about this kind of the function, just have to go through my video playlists. Just have to check GB Analytical School of Science solving polynomial inequalities. You come across this kind of a condition. Now as we are here, we are going to solve for the critical values in both the numerator as well as the denominator separately. So have x plus 2 is equal to 0, we'll have x is equal to negative 2. 5x minus 4 is equal to 0, we'll have x is equal to 4 over 5. So these are the key values that will be used, and we'll have to bring them on the number line and have to deduce the intervals corresponding to this negative infinity, like that. Now we have a sort of, let's say this is negative 2 and this is a 4 over 5. It should be that. And the intervals are given as negative infinity and negative 2. You also have negative 2, positive 5 over 4 should be that. And we can have it as 4 over 5 to positive infinity. And we should have to bring that on the testing table. And what are the intervals? We have the intervals should be that, the testing number should be that. And where should we have to test the number is into, we have x plus 2 divided by 5x minus 4 should be that. We have this. So we should have that one as that. And here we should have the conclusion on how we should have that one. So the first interval is negative infinity to negative 2, And what value should we have to choose? Let's think of having negative 3. So negative 3 here we have it as negative 1. Negative 3 here we have should be given as a negative 15, negative 15, negative 4, that is a negative 19. So negative 1 over negative 19, that is 1 over 19. That is the positive conclusion. And let's think of having negative 2, 5 over 4. That should be given as, which value should we choose? Let's think of having 0. And the 0 here, that is 2. And 0 here, that is a negative 4. We have negative 1 over 2. That is a negative conclusion. And the negative 2 should be 5 should be over 4 to positive infinity. We should think of choosing, let's say, positive 2. In the positive 2, that is 4. And here we have it as 10. In the 4, and 4 divided by should be 6. That is the same as 2 over 3. So hence we have 2 over 3. That is the positive conclusion. Therefore, we should have the set of our domain there. And the domain has to be the active intervals with positive conclusion. But now, on the domain, we should have to understand that the the key values that have been solved from the denominator should not be part of the interval because upon substituting them on the denominator, the function will be undefined. For instance, if we think of substituting 5 over 4 here, we'll have 0 on the denominator. Hence, that one should not be part of interval despite having the condition of that one. So keep that in mind. So therefore, have the domain being given as negative infinity, negative 2 part of interval, since it has been solved from the numerator, and the union will have 5 over 4 not part of interval, should be that. So this is the domain of the function. And what if, let's say, we have this kind of a case? Try to have this at the on time. Let's say I have f of x is equal, let's say, square of x squared minus, let's say, 4, and say divided by the square of x squared minus, let's say, 25. So how do you think we should have this? So try to have that one at your own time. And also try to have this. Let's say I have f of x is equal, let's say, square of x plus, let's say, 6. It should be that. And I divide by, let's say, square of, it should be x plus, let's say, 8. So try to have and how you should have to understand that at your own time. So that's how you should have to understand that. So now, how about, let's say, if we have this case whereby we have, let's say, f of x is equal, let's say, square of, x plus 2, and let's say divide by x plus 5. Let's say we have this kind of a case whereby we have a square root on top, and while down we have, let's say, just this. How do you think you can have that one, where it is a case we have a square on top? Now, when it comes to this case, we should have to determine the domain of the numerator as well as the denominator separately. And we'll use what we call as intersection technique in order to determine the domain of the whole function. Now let's start with the domain of the numerator. Domain of numerator. It can be that. And what is the numerator? We have it as the square of x plus 2. And what is the principle behind x plus 2? Should be greater than or equal to 0. And hence x would be given as greater than or equal to negative 2. Like that one. And on the number line, we should have it as, negative 2 here, and this is the positive infinity, and the negative 2 being part of the interval, we'll have it as, let's use this notation. That is should be that. And let's keep that safe. And we should now have to calculate the domain of the numerator. Domain of numerator should be the denominator, rather should be the denominator. So how should you have that on? Denominator should not be equal to 0. Hence x plus 5 should not be equal to 0. That will be given as x, it should not be equal to negative 5. And I should have that on the number line as well. That should be positive infinity. And this is negative infinity. We'll have negative 5 here. And in all cases, negative 5 it shouldn't be part of interval. Hence, we should have that. So it should be that. And now we have the domain of the numerator as well as the denominator. Now we should have to come up with what we call as the grand number line. The number line that will accommodate all the number lines for numerator as well as the denominator. And from there we'll have what we call as the grand domain of the whole function. So that's what we call as the intersection technique. So let's have should be the grand number line. And what are the values of interest? We have negative 2 and negative 5. So on the grand domain, it should be on the grand number line, we have negative 2, and this should be negative 5, and this is negative 2, and this is negative infinity, and this is the positive infinity. We should have that. And let's think of presenting the intervals that should be the intervals that we have. We have the first one, that is from negative 2 part of interval to the positive infinity. Should be that. And from negative 2 should be negative 5, like that. As you can see, negative 5 is not part of interval. So where do you think the two number lines are intersecting? So the number lines are intersecting from here to this direction. Hence the domain of the function will be from negative 2 part of interval to positive infinity. That's what we call as the intersection technique. So the whole of this part, there is no domain, since you should have to understand that from negative 2 and down here, there is no domain, since the number lines are not intersecting here. So go for the points in which the number lines are intersecting. That's what we call as the intersection technique of determining the domain of the function. And what if we have, let's say, this kind of a case? Let's say we have the function f of x is equal, let's say, square of should be x squared. We have this, let's say, x squared minus, let's say, 4 divided by, let's say, x squared minus, let's say, 25. So how do you think we should have the domain of the function, as you can see it here? So let's study the domain of the numerator. Domain of numerator. And now for that case, the numerator should be the squared function. And for that case, what you have to understand is that in all cases, x squared, minus 4 should be greater than or equal to 0. Now what we have is quadratic. Actually, what we have is pronomial inequality. So make sure you understand about solving the pronomial inequalities. Just have to go through my video breaks and check for that. And I'll start to factorize. We'll have x minus 2 and x plus 2 greater than or equal to 0. And what are the key values? We have x is equal to 2 and x is equal to negative 2. And I would have to present them on the number line, where we can have it as positive infinity and this is a negative infinity. And the key values, we have negative 2 and this is positive 2. and the intervals are negative infinity to positive to negative 2 and sort of like that. And we should have to bring them on on the testing table and check which interval satisfies the case of having the domain. And we have, let's think of having the intervals should be that, and the testing value, and it should be that. And where should we have to test the values? We have x minus 2 and the times x plus 2. Let's say that is the case. Let me just have to space here. So make sure that you are having the proper write-ups. So take note of that. You need to have the proper write-ups on whatever it is being scribbled here, and that should be able to follow. In the way we should have the conclusion should be that. And what's the first interval? We have negative infinity, negative 2. And which value should you be able to choose? We should have negative 3. And now for that case, negative 3 here, we have negative 5. And here we have negative 1, that is positive 5. And the conclusion is positive conclusion. In the other interval is negative 2 and comma 2. You should have to choose let's say 0. And so here negative 2, positive 2, that is a negative 4. And the conclusion is negative. And what else should you have to choose? By the way, let me take this one away. And let's think of having positive 2, rather should be positive 2 to positive infinity. Let's think of choosing 3. 3 here, that's positive 1. And 3 there, that's 5. We'll have positive 5. Hence, we'll have the positive conclusion. And now for this case, how should we have the set of the domain of the numerator? And now what happens is that the set of the domain will be the intervals with negative, should be positive conclusion. And since we have the condition of greater than or equal to 0, so we're looking for the positive conclusions, by the way. So the domain of the numerator has to be given as, should be that of the negative infinity to negative 2, and that should be part of the interval, and union in a positive 2 to positive infinity, and also part of the interval. Then you would have to present them on the number line. In the sense we use the intersection technique. And there we'll have the number line of interest that should be given as that. That is a negative infinity, and this is the positive infinity. So don't worry about the code of my writings. Just have to understand whatever it is happening there. Otherwise, my writings are such part today. So have negative 2, positive 2. In the intervals that are there, we have from positive 2 part of the interval to the positive infinity, and from negative 2 part of interval to negative infinity. So let's keep that. We should have to keep that, and let's go on the a numerator, and we should have the denominator of the numerator should be denominator. I should say the domain of denominator should be that. So how do you think we should have that? So in all cases, denominator should not be equal to 0, and we have x being given as 5. It should not be equal to should not be given as 5, and x should not be given as negative 5. So we should have the number line for that. That would be given as negative 5 and a positive 5. And that we should have it as the intervals being given as that, and also being given as that, and also being given as that. Then we should have what you get as the grand number line. The number line that will incorporate the domain of the numerator as the denominator. And at the end of the day, the set of the domain of the denominator will be given as should be that of negative infinity, negative 5 not part of interval union, negative 5, positive 5 not part of interval union, positive 5 to the positive infinity. Be meant that we have negative infinity here. So that will be the set of the domain and for the denominator. And now let's present what we get as the grand mean. Should be a grand number line where we have to present the number lines of the domain of both cases, numerator as well as the denominator. And what are the values of interest? We have negative 2, positive 5, negative 5, positive 5. So we should have to start with negative 5 here. And we should have negative 2, and we should have 2, and we should have positive 5 here. So that is. And now we have the first intervals. Let's start with from 2, part of interval, to the positive. And from negative 2, part of interval, to the negative. We'll have that. And we should have that one as well. That is from 5, not part of interval to this direction. And also that one, not part of interval like that. And also should be like that. So where are the intervals intersecting? So the intervals are intersecting from here. Let me have to demarcate. So the intersections are taking place from here, and I also have to be here as well. We are here and we are here. Should be like that. So which means the set of the domain will have them as, we should have these, the whole of this one, and we should have that one, we should have this one, and also we should have this one as well. That will be the set of the domain. So how should we have the domain of the function? Now we'll have the grand domain. And where the grand domain will be given as? Now the domain of the function will be given as, we'll start from this direction. So negative infinity should be to negative 5, but are not part of interval. That is the demarcation. And also inside we have union negative 5 to negative 2, part of interval. And union, there is nothing here because the intervals, the number lines are not intersecting, or the intervals are not intersecting. Then you have negative 2 part of interval, and comma 5 not part of interval. Should be that. And from positive 5 we are going to positive infinity. So have union positive 5 to positive infinity. So that's how you start to understand about how we can determine the domain as well as the range of such cases using what we call as the intersection method. And try this at your own time. Let's say if we have the function f of x is equal, let's say the square of should be x squared minus, let's say 36 divided by x plus 5. And also try this. Let's say we have f of x is equal, let's say square of x squared minus x plus, let's say should be minus 6. And divide by, let's say x squared plus x minus 24. So try to have the domain as the domain of that function in that way. So now, how about if we are to look for the range? Let's say we have the function f of x is equal, let's say 2x minus 1. So by the way, if we say a range, it is the output of the function. So we should have to understand that having f of x, it is the same as having it as y is equal to x minus 1. we should have to make x as a subject here, hence we have it as x is equal to y plus 1 divided by 2. As you can see it here, this is linear inequality. So therefore, the range, the range of the function will be negative infinity to positive infinity. It should be that. And how about, let's say, if we have the function, let's say f of x is equal, let's say, 2x minus 1 divided by, let's say, x plus 5. So how should you have the range of the function? Principle remains the same. Having f of x, it is the same as having it as y is equal to x minus 1 over x plus 5. Where I'll have to cross multiply, I'll have it as 2x minus 1 is equal, we should have it as xy plus, we should have it as xy plus 5y, and we should have to bring those with x together. I'll have it as 2x minus xy is equal to 5y plus 1. We should have to factor out x. We have 2 minus, we should have 2 minus y, and which is equal to 5y plus 1, and therefore x is equal to 5y plus 1 divided by 2 minus y. Now what we have, it's a fraction case. So how do you think we should have the domain should be the range of the function? Now in all cases, 2 minus y should not be equal to 0. Hence you can take it from there, the way we have discussed about this, that one. And what if we have, let's say, f of x is equal to x to the power 3 minus 5 over, let's say, x to the power 3 minus, let's say, 6. So how should you have the range of the function? Principle remains the same. We have y is equal to x cubed minus 5 divided by x cubed minus 6. We should have to cross multiply. We have it as, should be x cubed minus 5 is equal to yx cubed minus 6y. We should have to bring, those with a cube, x cubed together, should be with x together. That will have negative 6y plus 3. And we have to factor out x cubed. We have it as 1 minus, should be that, in the negative 6y plus 3. And that will have it as x cubed is equal to negative 6y plus 3, and divided by 1 minus y. We'll have to introduce cube both sides in order to eliminate the cube. Actually, power 3. We'll have it as, should be x is equal to the cube root of minus 6y plus 3 divided by 1 minus y. So how do you think we should have this one? So try to apply the same concept we discussed about having the cube roots with a fraction side. So that's how you should have understand about how we can have the domain and the range of the functions analytically. And sorry for my videos today, because I was lacking the consistency in the writings. In fact, I was somehow tired, but just have to understand the concept, and wherever you have problems in the understandings, you can leave us through more to my videos related to whatever I've expressed here. Thank you.